Hello, welcome to Applied Math. This time I'm going to show you kind of a way to get your hands on the idea of 3, 4, 5 triangles and why they're useful in the construction industry. Okay, so for this exercise you'll need a piece of paper. All right, you'll need a pencil. All right, now if you had a ruler you could use a ruler too, but just trying to get with the very basics what everybody would be able to have. Hopefully everybody has a piece of paper or at least a piece of mail or something and a pencil. Okay. Now the piece of paper does have to have, has to be cut square. All right. So first thing I want you to do is hold it up in the hot dog style or the long end up. Okay. And really, you're going to take one corner up at the top, and you're just going to make a mark, little crow's foot, I've heard it called. Okay. Where you think an inch is from the corner. Okay. Now it doesn't have to be exact. It really doesn't matter, which is one of the cool things about this principle. It doesn't matter what unit you measure in; it's still going to work. But just go ahead and, just go ahead and use, this is 1 inch here, okay? What I'm going to say is an inch anyway, approximate, okay? And really what this is going to become my measuring device now. All right, so I'm going to tear off a piece of paper here at the corner, okay? And now I've got an inch to measure with. All right, so here's my inch from this point to this point. All right. Now, if you take your piece of paper, okay, and you're going to make it hamburger style now, okay, with the tore off part up top, okay, so that we have a complete, full, uninterrupted edge here on the bottom. All right. From one corner, you're going to measure. We're using your measuring here. You're going to measure 3 of your inches and make a mark. So I'm kind of going to use my little inch and hop skip till I have 3 of my inches here. Like this. So now I've got 3 inches from the edge of my paper to here. All right, then I'm going to go along the other edge and I'm going to mark out 4 inches. Like the following. So now I know that this is a 90-degree angle here, at least if the paper company cut it right. Okay, this is a 90-degree angle right here. And I went 3 inches one way and 4 inches another way. And if I connect these two, I have a triangle, and I have a 3, 4 triangle. And I want you to measure using your little inch. Okay, measure how many inches is it from one. How many inches is this diagonal? Okay. Now it might be useful to take another piece of paper, okay, and go ahead and just draw a line here, a straight edge. So take another straight edge and connect these 2 marks, and then measure it with your. And if I do that, okay, I end up with 5. Okay, I count the spaces here, the amount of whole inches, 1, 2, 3, 4, 5. And kind of informally, just with my little hands and paper, I've confirmed that, hey, a 3, 4, 5 triangle, okay, has a 90-degree angle right here between the 2 shorter sides. Now why is this important? Again, because we build in 90 degrees in our culture, okay? Build boxes, right? Lots of 90 degrees. So as many tools as we have, many methods we have to confirm that we built something at a 90-degree angle, we call it built it square. All right, the better we're off. Okay, so using 3, 4, 5 triangles will help us with building things square. All right, now I say 3, 4, 5 triangles because we can use the 3, 4, 5 here triangle. We can also use a multiple, okay, or a little bit scaled up version of one. And for that one, I'm going to write on the other side here, okay. And I'm going to go 6 inches across here and 8 inches up, and I'm going to measure to confirm that this is 10 inches. Alright, once you do that, you should get something that looks like this. Okay, so I've got 6, 8, and I did measure, and I ended up with 10 here. Okay, and look, it works. Okay, this is definitely 6, 8, 10 triangle. Definitely has a 90-degree angle in between the 6 and the 8. Okay, so if I were to measure some walls, 6-foot wall here, 8-foot wall here, and I measured the diagonal, if it was 10, then I know that I'd set up my walls square to each other. All right. Now there's several other ones, 3, 4, 5, 6, 8, 10. Okay, I want you to also remember that we can have 12, 15, 20. Okay, sorry, I said that wrong. 9, 12, 15. Okay, which is the same thing as, taking the 3, 4, 5 triangle and multiplying it by 3. We can also take the 3, 4, 5 triangle and multiply it by 4. Okay, and we can multiply it by 5. And we've got that whole list of 12, 16, 20, 15, 20, 25, 3, 4, 5, 6, 8, 10. Okay, and again, I apologize for my handwriting, but these are the 5 that I kind of want you to become familiar with, or at least be able to produce pretty quickly. Okay, and remember, all I'm doing is just multiplying the 3, 4, 5, the sides here, by a consistent number. In this case, 2. In this case, multiplying all of them by 3. Multiplying all of them by 4 to get these, and multiplying all these by 5 to get these. Okay. And don't forget, there's also that 5, 12, 13 one. Okay. And all of these can be confirmed by the Pythagorean theorem. And that's all that I have for you.